After he received his diploma in 1896, he was finally admitted to the Zurich Polytechnic. As a student at the Polytechnic, he often failed to attend lectures, opting instead to work on his own by reading the works of great pioneers in science and philosophy. It was here where he met Mileva Marić, a fellow student and his future wife. He also met Marcel Grossmann, a brilliant mathematician who took meticulous notes during the many lectures and gladly let Einstein study these notes before the final exams. Einstein graduated from the Polytechnic in 1900 at the age of 21. In 1901, he gave up his German citizenship and became a Swiss citizen. In 1902, his friend Marcel Grossmann came to his aid again. Marcel helped ʻAɪnstaɪn get a job in the Swiss Patent Office in Bern, Switzerland. To ʻAɪnstaɪn, his years in the patent office were time well spent. Working on other people's patent applications taught him to express his ideas more clearly in writing. It also gave him the opportunity to think about physics in his spare time. In 1903, he married Mileva Marić. Their first son, Hans Albert, was born a year later. During the day, he worked in the patent office. At night, he worked on his beloved physics and the many ideas that were floating in his head. In 1905, he decided to put these ideas down on paper. Einstein wrote a number of articles for a German magazine for scientists. It was called Annalen der Physik, or the Physics Annals. After reading those articles, scientists would never think or work the same way again. One of the papers dealt with the photoelectric effect, which concerns the emission of electrons from metal surfaces exposed to light. Theoretically, this study represented a cornerstone of quantum physics and would make it possible for many future inventions, such as television. Another paper dealt with providing a method for determining the dimensions of molecules. The third paper was titled On the Electrodynamics of Moving Bodies, but would soon be known forever as the Special Theory of Relativity. Sir Isaac Newton had called time and space absolute, meaning that time flowed in a constant stream. Time, he stated, was the same for everyone, regardless of location. Einstein proved Newton wrong. Einstein wrote that time and space were relative and that they depended on a person's location in relation to objects and events. Another conclusion from this paper deals with mass and energy. Einstein believed that matter and energy were different forms of the same thing. This is the meaning behind the famous equation E equals mc squared, which translates to energy equals mass times the speed of light squared. This formula told scientists that every tiny atom, the smallest unit of an element, contains a great deal of energy.
It followed from the special theory of relativity that mass and energy are but different manifestations of the same thing, a somewhat unfamiliar conception for the average mind. Furthermore, the equation E is equal mc squared, in which energy is put equal to mass multiplied with the square of the velocity of light, showed that very small amount of mass may be converted into a very large amount of energy, and vice versa. The mass and energy were in fact equivalent, according to the formula mentioned above. This was demonstrated by Cockcroft and Walton in 1932 experimentally.
It would be 40 years before the world knew just how much energy could be released from the atom.